All right, 8th grade classes, I'm going to walk you through and explain the 3D modeling project for our topographical maps that we're going to be doing. And so here's a picture of one that was done. You'll see it up in the front of the room. And I'm not saying this is a great example, but it does bring out a couple things. Number one, we can see all the different layers of cardboard. Each one of those layers of cardboards represents a change in elevation. And based upon our contour interval, we can figure out how much elevation change there is. Okay, we'll take a look at that in just a second. A couple things I want to point out as we do this. One, I want you to see that there's a river flowing right down here. One thing that's not correct about it is that it isn't blue, and I'm going to ask you to do that. One thing that is well done is that you see the V pattern in each of these, the V pattern as it passes through, and that's one of the features that we see when we see a river, because we know that the river has to be a little bit lower for the water to flow into it. So that's a basic look. To a peak here, and a crater here with hash marks, and so we'll touch on all those things as we go through. Starting out here, taking a look at the course calendar on my website. If you've got access to the calendar on your device, certainly the same thing. So we'll click on yesterday's because we wanted to get to it, but we're getting to it today, and 3-day project info. As that loads up, we're going to see the information that you're going to need, and so I'm going to go through this step by step. First of all, you have to determine your map size, and the first thing you're going to do is going to make a map, and it'll be flat, just a piece of paper, and you're going to draw it. You're going to draw out your map, but what you need to do is decide how big you're going to make it. 1 foot by 1 foot, 2 feet by 2 feet, 1 foot by 2 feet. It's fine. I would recommend not going more than 3 by 3. It just ends up being too much cutting and too much space. So 1 by 1 is perfectly fine. And then you're going to cut your piece of paper to match. So there's some large pieces of paper up front. You may have to tape some together. You may have to cut it down, but it needs to be the exact same size as your cardboard. Okay? And then you're going to make a map. You're just going to draw it on there. And remember, we want to think about a couple things. One, on a topographic map, every line represents a level elevation. And so we usually see lines that somewhat look like other lines near them. We should see circles when we see mountains, so on and so forth. So we're going to work on that. Things you're going to include are 2 peaks, and then it says right in there, think about circles inside of circles, 1 crater, 1 river, 1 ocean, and your contour interval is 50 feet. That means each line represents a rise of 50 feet in elevation, or a drop in 50 feet of elevation. Your overall relief is 500 feet. What that means, the relief is the highest elevation minus the lowest elevation. We should have 500 feet, and we're going to include an ocean, which means we're going to start at 0. So when we talk about elevation, sea level is 0. So we're going to go off of 0. So you need to have at least 11 layers of cardboard. I hope you do even a few more. All right. So what you're going to do as you go through that, so you're going to draw it on there. And you're going to label each and every contour line's elevation. We usually don't see this on a map, but for this project we're going to do it. This is going to help you minimize cutting mistakes because you'll be able to see. Now you might have something that's a circle, or you might have something that goes off the edge of the page. Let me show you what I mean by that. So for example, you might have something that goes off the edge of the page. Not seeing a good example of it here. Oh, excuse me, yes, we would. So for example, this line and this line are the same elevation. This line and this line are the same elevation. Remember that they go up by 50 feet each time. So you're going to want to keep track of that as you put it all together. So that's why I'm having you label every single one of them to help minimize mistakes. And once you have your labeling done and you've drawn it all up, you've got all the things A through F included, then I want someone in your group to take a picture. So hopefully someone's got a phone, a tablet, or something like that. And maybe you can even borrow one and then just have them email that picture to you. We're going to want that picture at the end when we're done. Then you can cut out the lowest layer, the lowest contour line, and transfer it to the cardboard. So you're going to cut it out, trace on a piece of cardboard, make that cardboard fit. All right? You're going to use a lot of cardboard for this. So recognize that, especially early on. Again, go back to the picture. This piece right here, you can kind of see it, that's the edge of it there. It goes back to there. It extends all the way through underneath all of these back to here. Right? So go look up at the example if you don't know what I mean. When you get to work, again, this is on the front counter, and figure that part out. Continue step 5 until everything's cut out and transferred to cardboard and cut out. Once you're sure it's all accurate, I would put it together without glue. Make sure it looks right. Make sure you got A through F taken care of here. All right. And then you can start to glue it together. All the water is blue. Okay, a couple things to keep in mind. Number 1, contour lines never, ever, ever cross because each one represents a level line of elevation. Rivers should always have a V pattern pointing towards the source. So I put an example in here for this sheet, and there are some of these sheets up in the front of the room you can use. Some great links here to help you out in terms of your understanding and ideas. Okay, and then how it's graded, pretty simple here. We got 10 possible points, 2 points for 2 peaks, a crater, a river, 1 ocean, and then the accuracy. How well did you transfer from your map to your model? That's why you're going to include that picture. Okay, on the crater, before I let you get to work, on the crater, what I want you to see in the picture is, it's a little bit in there. Let's see if I can zoom in a little bit, get a look. There we go. And you see the little hasher marks right there. That represents depression. Okay, that represents a low spot. So this group actually didn't do it right. They should actually have cut that line in this piece of cardboard, and then they should have cut this line actually in this piece of cardboard, so it shows that it goes down in. A mistake that they made, we still want to include the hasher marks. Again, if you look at these links, especially this one, the link to helpful info, check that out. It's got some great information, some great definition of terms, and it'll really help you understand as you go. Okay? Yeah, so we're going to go ahead and work. Mr. LaFew is going to get you set up, and I'll see you on Monday.